It's Monday, you're going to be multiplying decimals. Copy this down into your notebook as the title for today. The question we're going to answer is, how can the standard algorithm be applied to multiply decimals and whole numbers? So here's the activator. At a grocery store, 1 pound of apples costs $1.12. How much money will it cost to buy 6 pounds of apples? Pause the tape and figure it out. Okay, one way that you can solve this is by adding $1.12, $1.12, $1.12, $1.12, $1.12, $1.12, and $1.12. That even took a long time for me to say. That's not the most efficient way to solve this problem, although it will work. There's a much quicker way to do it. And if you're thinking that multiplication is another way to do repeated addition, you're right. So what we could do to solve this problem is $1.12 times 6. So the cost per pound of apples times 6 pounds of apples. Now the first thing I want to think about is, I realize that 1 pound is $1.12, so it's a little bit more than $1 per pound. So my total price, since I'm buying 6 pounds, has got to be more than $6. It's probably going to be somewhere close to 7. So let's work this out. And when you multiply decimals, you can do it just like you're multiplying whole numbers. You start with your ones place. 6 times 2 is 12. You write the 2. You carry that 110 up. 6 times 1 is 6 plus 1 is 7. 6 times 1 is 6. So we have 672. But I know $672, that doesn't make any sense. So I'm buying 6 pounds of apples. Each one costs a little bit more than $1. That does not make any sense. So here's the key. When you multiply decimals, it's right here under the star, and this needs to get copied into your notes. The total number of digits that are after the decimal place also have to be after the decimal place in your product and the answer to the multiplication problem. So when we look at this problem, we have 2 digits after the decimal place. Here's our decimal place right here. The 1 and the 2 are both after it. There's no decimal place here. So our final answer, we must move in 2 places, 6.72, and in this situation that represents $6.72. That's a very reasonable amount, and if you were to do $1.12 added up 6 different times, that is exactly what you'd get. Okay, so when you multiply decimals, again, you multiply just like you're using whole numbers. If you use an array or a box method, it'll still work. You just have to include your decimal point at the end. So 8 and 31/100 times 5/10. I have it set up here, and notice I cut out this leading 0. There's no reason to do that. First thing I'm going to do is count the total digits after the decimal place. So I know in my answer to make sure I include it. And I have 1, 2, here and 1 here, so I have a total of 3 digits after my decimal place. So in my product, I need to move my decimal point over 3 places. Now when I estimate this, this is slightly more than 8, and this is 1/2. So I know that half of 8 is 4, so this answer should be around 4 somewhere. Now I'm just going to multiply this out. 5 times 1 is 5. I have nothing to carry. 5 times 3 is 15. I write my 5. I carry. 5 times 8 is 40. Plus 1 is 41. So 4155. And I know I have 3 digits after my decimal point, so I need to move in 1, 2, 3 places. And that looks pretty good because in the very beginning when I thought about my estimate, I thought, okay, this is about 8. Half of 8 has to be around 4, and my product is around 4, so I can be fairly confident that I'm correct. On the bottom are 3 problems. Go ahead and pause the tape and give all 3 of these a try before you unpause. Okay, so here we are, my first problem, 4.35 or 4 35/100 times 8. First thing I'm thinking, this is around 4. 4 times 8 is 32, so my answer is going to have to be greater than 32 because this is a little bit more than 4. Also, I see I have 2 digits after my decimal point, so I'm going to need to have 2 digits after in my solution. From here, it's just simple multiplication. 8 times 5 is 40. 8 times 3 is 24 plus 4 is 28. 8 times 4 is 32 plus 2 is 34. So 3480, I need to move in 2 places, 1, 2, 34.80. Again, let's see if that's reasonable. I know my answer had to be around 32, a little bit greater, and I am a little bit greater. The second one, 2 and 12/100 times 7/10. Well, I know this is a little bit more than 2, and this is less than 1. So if this number were 1 whole, my product would be 2.12. Because it's less than 1 whole, my answer is going to be less than what I started with. So I'm going to count my digits after the decimal place. I have 1, 2, 3, so I know I'm going to have to put 3 digits after my decimal place. And then from here, it's just simple multiplication. 7 times 2 is 14. Carry my 1. 7 times 1 is 7, plus the 1 I carried is 8. And 7 times 2 is 14. So 1,484 is a gigantic number. It's way too big. If I moved in 1 decimal place, 148.4, way too big still. 14.84, way too big. I have to go in 3 decimal places. 1 move, 2 moves, 3 moves, 1.484, a very reasonable product. The final one, the word problem. At the store, bulk candy. That's like a bunch of candy. Sells for $3.15 a pound. How much will you spend if you plan to buy 7/10 of a pound? Again, if I bought a whole pound, I'd be paying $3.15. But I'm buying less than a pound. So my total has to be less than $3.15. And right away when I look at this, I see 1, 2, 3 digits after my decimal place. So I'm going to have to move in 3. Now I just simply multiply. 7 times 5 is 35. I write my 5. I carry my 3. 7 times 1 is 7, plus 3, 8, 9, 10. Carry my 1. 7 times 3 is 21. 21 plus 1 is 22. 2,205 would be an absurd amount to pay for less than a pound of candy. I know I have to move my decimal place in 3. 1, 2, 3, $2.20.5. So since we're talking about money, I could probably round this up to $2.21. Okay, anything you need to copy down or rewatch, rewind the tape and do that before moving forward. All right, 2-digit by 2-digit multiplication using the standard algorithm. The same idea holds true. If I'm determining the product of 2 and 5/10 and 87, first thing I'm doing is noticing, okay, I only have 1 digit after my decimal place. Now, I'm going to multiply as I multiply. 7 times 5 is 35. I write the 5, I carry my 3 tens up. 7 times 2 is 14. 14 plus 3, 15, 16, 17. Now, a couple things here that could easily go wrong if you don't pay attention. The very first thing I'm going to do is I'm going to cross out this because I'm done with it, and I'm going to put that 0 there to represent that place value, which I'm not multiplying this place value anymore. The other thing I'm going to do is anything that I keep track of up here, anything that I had to carry over, I'm going to erase it so I don't get it confused with what I'm going to do now. Because now I'm going to multiply this 8 up here. So 8 times 5 is 40. I write my 0. I carry my 4. 8 times 2 is 16. 17, 18, 19, 20. And that's it. Now I just find the sum of what I multiplied. 5 plus 0 is 5. 7 plus 0 is 7. 1 plus 0 is 1. 2 plus nothing is 1. I move my decimal place in 1 spot. I have 217 and 5/10. Let's think about that if that makes sense. Well, this is about 90 right here. If I doubled 90, if I just times it by 2, I'd have 180. But I'm multiplying it by 2.5, so 217 really seems to make sense to me. The key here, there's a couple things, is first, why the 0? This 0 right here, when I'm done with this place value, when I finish multiplying this 7 ones, I put the 0 here to hold that place. Because now I've moved over a place value. I'm not messing with this anymore. The other thing that was important here, if you notice, if you rewind the video, is once I got done multiplying the 7 by the 5 and the 7 by the 2, I erased what's up here just to keep everything a little bit easier for myself. Alright, go ahead right now and pause the tape and see if you can do 2 things. First, I've started this problem. See if you can fill in the missing pieces here and then get the total product. And then second, answer the word problem on the bottom. Okay, so here it is solved out. 8 times 5 was 40. I carried my 4. That's in blue. 8 times 4 is 32 plus 4 is 36. I finished it out. On the bottom, here it is. Feel free to pause it and check it out. And your work for today is right here. It's bit.ly/ISMD1.